This is just a short presentation to show you what you'll be measuring in this lab and the instruments you'll use them for. And actually it'll show you the measurements themselves so you can get all of your data from this little presentation. And I'll post this PowerPoint so you can go through it slowly if you want to. You can also pause it while you're doing it. Where am I? So here's one of the devices you're going to be measuring. I think using the newer meter, I forgot to measure that 2000 centimeter number 30 copper spool down there, but I did get it with the other meter. Okay, by connecting to these various posts on here, if you connect an ohm meter to this post and this post here, you can measure the resistance of this wire. And what it means is, it says 10 meters, 22 copper. That 22 is the gauge of the copper wire, and so that's something that you need to pay attention to in this lab. And then you'll measure 10 meters of 28 copper wire, that's 28 gauge copper wire, and then 20 meters of 22 gauge copper wire and 20 meters of 28 gauge copper wire. So those are the things that you'll be measuring in the lab, as well as I've got some other little gadgets here. These are some little spools of copper wire. They're all number 30 copper wire, 30 gauge copper wire, and 40, 80, 120, 160, and 200 centimeters on those. So that's something else you'll be measuring. And the number 30 here, sometimes the number sign is left off, but that means the gauge of the wire. This happens to be NS wire. I don't know what the NS stands for. I've looked for it before. If it's an alloy, alloys can occur in different concentrations for the different metals, and there's no telling just from that NS designation just what it means. So unfortunately, we can't do anything more with that. Here's a meter that's much like the ones that you have, and its finest division is just 1/10 of an ohm. And on the reading it's showing right now, 0.0 ohms, it's actually got the leads shorted. I have them alligator clips at the end of the leads, and they're connected together. And so that's what the reading is when those things are connected together. And then here are the first 4 measurements for this thing, and you could pause this here and copy these down. These are all with the number 30 or the 30 gauge NS wire, whatever the heck that is, and 40 centimeters here, 80 centimeters here, 120 here, and 160 there. And then the next slide is just the 200 centimeter 30 gauge NS wire. And so you can see what all those ohm readings are there. And from those 5 measurements, you can determine the resistivity of that NS wire. And then here is that same ohm meter, but this time it's measuring on the other spools that we have. And so these ones, you've got some variation. This is 22 gauge. This is 28 gauge, 22 gauge again, and 28 gauge. But if you're clever, you can still make a single graph that has all of those measurements in it. You just need to be a little bit more clever about it than we have been. So you'll be able to make a single graph. And then here is this one. I did remember to take a measurement of the 2000 centimeters of 30 gauge copper wire. And so this graph with this older ohm meter could have 5 data points on it. And from that line, you should be able to get the resistivity of the copper wire. Then we can go a little bit better. I only bought one of these. These cost a few $100s, but this can measure resistivity, or the resistance, excuse me, to the nearest thousandth of an ohm. And when I have the leads shorted on this, they happen to say 0.031 ohms. Now, the other one would stop reading at the 0.0, and so it may be that the resistance of these leads happens to be 0.031 ohms, but the other one would still read that as 0. So that's something we have. Okay, and then here are the resistances of the NS spools going left to right on the top row: 40 centimeters, 80 centimeters, 120 centimeters, and then 160 centimeters. And on the next slide is that same wire, 30 gauge NS, and 200 centimeters on that one. So you could back this up and pause it on the previous one and get some more precise measurements for these. And with these 5, you should be able to determine the resistivity of that wire, whatever it is that it happens to be. And then here we're doing the copper wire on the other spools again, and there are the first measurements, or the measurements of these 4 copper spools. And I think I did not take a measurement, or at least I didn't take a picture of the measurement and have it in my camera. Didn't get the picture of the that 5th copper spool, and so with these you'll only have 4 data points. However, I think these 4 data points are a bit more precise than the other ones, and so should be able to get more information out of that. Anyway, those are the data points that you'll be using in this lab.